Our last speaker of tonight is Rohit. He is the product manager of Galaxy, which is Meteor's own platform as a service, sort of for running Meteor apps. And he'll be talking about the tools that we use to sort of make GraphQL work in development and production.
Thank you, Jonas. Let me fire up the presentation here. Great. Let's get started. So good evening, everyone. My name is Rohit Bakhshi. I'm responsible for product management here at Meteor Development Group. And what I'll talk about today is talk about our production app that we have, Galaxy, and then go into how we incrementally adopted GraphQL, why we did it, why it was important, what it helped us kind of enable and accomplish with Galaxy, and then how Apollo and incrementally adopting it with Apollo was really, really useful in rolling this out to production, and then share key learnings that we had with the app and with our experience. So let's start with Galaxy. So Galaxy is a platform as a service for Meteor JavaScript applications. Think of it as Heroku for Meteor.js connect-to-client applications. This has been in production since October of last year. It's almost been a year that we've been in production. We've got thousands of users, thousands of applications deployed on our platform as a service. And what you're looking at is actually the management interface for Galaxy. This is what users use as the app to manage all their applications, look at all the data for their applications. So it's a very data-intensive, rich client experience. And the way we built it and architected it is that the entire platform is built on AWS. We leverage AWS for infrastructure and underlying data services. We use MongoDB for our operational data store, and the actual app that you're looking at is a Meteor JavaScript app. So it's React framework in the front end, and then a Node.js Meteor backend that then talks to these different data sources, right? So we have MongoDB as an operational database. We use Amazon DynamoDB for all the container metrics. So when you're running containers, you want to calculate RAM and CPU utilization and get those metrics. That actually goes into Amazon DynamoDB. We use Elasticsearch for app logs. So we've got different types of data stores that are powering that user interface. And so as we scaled and as we kind of grew our business and as more and more customers came on board with using our platform as a service, we started seeing that the performance of certain pages was kind of degrading from where it was before, right? Here's an example of what we kind of found. So as an account, so this is, you're looking at an account and you have a list of applications in an account. As you have accounts that have 10s or 20 applications running in them, what we're doing on this page is that we're actually hitting MongoDB to get, there's one call to get the list of applications that account, and then for each of those applications that account, there's multiple calls to get summary data. So we get data about who deployed it last, we get data about Spark lines to show you CPU trends over the last 24 hours, RAM trends over the last 24 hours. So that's a lot of data being loaded for the entire list of applications. And this is a great example of a page when you're making multiple different endpoint calls, becomes slower and the load time becomes impactful to our customers. Another example of that is for a single application, we actually provide pretty rich container metrics. So one application can have multiple containers. We use Docker to run and orchestrate these containers across different EC2 machines. So for one application that has 20 containers, we have applications that are running 40, 50, 60 containers. You have all these charts that are giving very data-intensive views into RAM and CPU and number of connections. And each of those is, again, hitting an endpoint to render each of those individual graphs. So again, a very data-intensive view that gets expensive and impacts load time, and impacts the end customer experience. When you're working with these data-rich user interface front ends, hitting multiple different backends. And so that's why GraphQL is really important to us as a team when we were developing and dealing with the scale that we were growing at, right? So one obvious thing is that once you have GraphQL queries that go across these different data sources and power and one query that then pulls the information to power that and render that UI, you don't have the multiple round trips for every single individual graph. And that's a big front-end improvement and a big reduction in load time, as well as developer productivity. So we have front-end developer applications that are working with data sources, different data sources, right? So one schema that's defined across those different sources and using tools like GraphQL. So we use that while developing, and it's really, really useful. It's immensely impactful and helpful to our front-end developers to build new functionality, maintain existing code and existing queries. And so GraphQL is really important in that sense. Now, as we kind of thought about rolling this out to production, right? We have this application. It's been running for months. We have thousands of users. We want to do something in a way that doesn't tear apart or completely re-architect the application. And so we were big on incrementally pulling in and adopting GraphQL for certain pieces. And so that's where Apollo and Apollo's approach of incrementally being allowing you to adopt GraphQL as a data layer into an architecture alongside your existing data layer. So not rip and replace, but incrementally adopt was really, really important. And so I talked to other customers who are also looking at using GraphQL. And when they have production applications, it's a very similar story. They want to incrementally adopt it and not just rewrite the entire application with a new data layer. And so how that kind of plays out in our architecture is that the same diagram that you were looking at before, we now have an Apollo client piece and kind of part of the architecture that lives within our React front-end client application. And that's hooked up to certain components that are powering the pages that are actually using GraphQL to render those pages. So they use Apollo client, and then the other components in the React application are using the REST, like we have a Meteor DDP subscription data loading framework that we're using. So they exist side by side in our application. And then Apollo Server, so what Nick at Credit Karma was talking about using, Apollo Server is a component that lives within our Node.js Express or Node.js Meteor backend. And it's used to then, the resolvers and the logic is kind of lives in that component to talk to MongoDB to get operational data for the application, as well as from Amazon DynamoDB to render those metric views that you were seeing. So it's incremental, lives alongside existing architecture, and we can keep adding we can keep instrumenting and orchestrating new components and pages with GraphQL. So now I'm going to switch over to show you what this actually looks like running live. So let's see if I can share my screen and do this on the large screen. Can everyone see that? Okay, great. So this is our corporate account, actually, MDG. Make it bigger? Let's see. Okay. This is our corporate account, a Galaxy corporate account, and we have multiple applications here that are in the account. And you can see the same. You can see summary information and metric information about each of these. And so what we actually did while we were building this is that we've also built production tooling to help organizations such like ourselves with Galaxy implement GraphQL and run in production. And have the confidence to run in production. So I'm going to zoom into this a bit. So Apollo Optics is the tooling that we created. And this is a preview that you're looking at here. And what we have here is all the different queries that are actually going through the GraphQL service infrastructure that's powering Galaxy. And so get user apps is a query here. This is the query that's actually rendering that page I was just showing you. So I'm going to go look into this and click on that and actually because this tool is capturing information over the course of time as to how many times those queries are being rendered or executed across the different query requests, I can get a view of kind of an idea of how it's performing over time. So latency duration histogram to see that about half the time the query is executing under 100 milliseconds. But there are a few outliers here that go into 3x, 4x, 5x range of executing the query, right? So I want to go and see what's happening there, and I can go click in and actually see, I have one loaded up here, a very visual introspection and view of what's happening. How is the GraphQL query actually executing, right? So what you're looking at here, and I'm going to zoom in here, you're looking at a breakdown of all the different resolvers as the fields are being executed and data is being fetched for those different fields. So this is the query that powers that page that I was showing you. So for an account, get a list of applications. For each application, get information and go through that and iterate through the list of applications. And you're seeing that play out here, and you get a sense of how long it takes to get each application. You're getting a sense of which are the most durationful resolver executions, and you can see here a lot of them point to the app.metrics, metrics, which is the resolver that's actually hitting DynamoDB and getting the summary information, metric information for each app in the list. And so this has been really helpful. So our front end, Tim, who's our engineer who implemented this, was showing me what he got out of using this tool. So here's an example here's a trace that we actually captured multiple months ago when we rolled this out into production, when we rolled Galaxy out and Apollo in Galaxy out into production. You can see here, this is the execution path for the same query that I was showing you. Every single application is being fetched in sequence, right? And so this is when we first rolled out the functionality, first rolled out the integration, seeing it in a very visual manner. You can kind of see how the execution's happening. And this pointed us to the fact that we were doing this synchronously, and we should have actually implemented asynchronously. You can see the benefits that we then get going back to what this actually looks like right now. This is after optimizing and kind of learning from the different architecture things that we rolled out before. And so it's really helpful. So GraphQL as a service layer and infrastructure sits above all the different backend endpoints, and so it's a really nice way to then introspect what your front end's doing, how it's querying for information, what field it's using, and so tooling like Optics really helps you figure that out. So to summarize, what are the key takeaways that we had after rolling this out to production and experiences with running GraphQL in production? One is that incrementally adopt a major new data layer like GraphQL. And Apollo client and Apollo server really helps you do that. And it's helped us because now that we've got a few of these components and pages orchestrated and kind of loaded up with GraphQL, we can then make choices about how to roll it out to other pages as it makes sense in our application. And for a data-intensive front-end application like the Galaxy management interface, GraphQL not only improves client load and application performance, but it also helps our developers be a lot more productive. So those are definitely learnings that we've seen over the last 2 months of running this in production. And having tooling and having a way to view from a very GraphQL-centric way how your front-end clients are asking for data from the backend services, what queries they're executing, how those queries are actually getting executed in real time across different parameters is really helpful in figuring out where to optimize and how to make your load times faster and how to be more intelligent about how you use your different data points that you're kind of exposing from your backend services. So thanks for listening. I'm available. If you ever have any questions about running apps or implementing GraphQL into production apps, hit me up on Slack or hit me up on Twitter. I'd love to kind of answer questions and talk about that, as well as if you want to see previews of the tooling that we built. I'd love to talk about that as well. Thank you.
All right, thank you, Rohit. I think we have a couple of questions, so we'll take those.
So I don't know too much about upload client, but I know in the React, most people are using Redux. So can you do a comparison to say in what kind of case, what kind of role upload client plays in such case, and do a comparison between Redux and the upload client? Thanks.
It's a great question. I think engineers working on Apollo client might be better at answer. So Jonas, you want to take that?
Okay, actually, yeah. So actually, Apollo client works really well alongside Redux, and Sashko could probably tell you a whole story about how we made it to work really well with Redux. So yeah, totally. If you have a React application and you're using Redux in there, you can use Apollo client. You can either have 2 separate stores, one that's managed by Apollo client, or one that's managed, for your local app state in Redux, or you can actually pass that Redux store to Apollo client and make it use just one store, so you have everything managed in one place, and you just have, your one set of reducers.
Oh.
I'm curious to know how you do the timing thing, like in your optics, without middleware. Like, what approach you actually take for doing the timing?
The question is, how did we get this timing approach, which I'm going to switch to see if I can. So this is actually orchestrated by middleware that's sitting in the Apollo server as a package. So there's actual middleware that we've used that is a trace logging middleware that is collecting traces for the different query requests and then sending it back to the service. So it does use the middleware. Yeah.
Although you can use the same thing with any JavaScript GraphQL server, because what we do is basically just wrap the resolve functions and then set an object on the context that it writes the timing to. And then that gets sent to the optics backend.
Yeah. Yeah, so this works with Apollo server and Express GraphQL and Happy GraphQL and different GraphQL servers. So it's good. Yes, question on that?
So 2 parts. First of all, are you using GraphQL subscriptions at all? And the second thing is, what kind of caching are you doing, for example, on your slow Dynamo queries, which in this case take a long time, but what kind of caching do you have implemented there to speed that up?
Good question. So on the first one, we are not using GraphQL subscriptions yet. That's something we'll explore. We're actually using polling with our GraphQL queries to render those. And those pages that we use, we didn't need to make it real time, so we didn't have to use GraphQL subscriptions. On the caching thing, I'll follow up with you on that one. I don't know what we're doing on the back end there to optimize loading from DynamoDB, but we can follow up on that.
All right, we have time for one more question.
Hey, yeah, I'm just curious, what's the future of optics? It's something that I would definitely be interested in having.
Yeah?
Yeah.
Good question. So we're really focused on, once you've built and implemented GraphQL service in your architecture, there's a whole set of things that a whole set of answers and questions that front-end developers and front-end people who are in charge of the front-end architecture can ask. Things like, which fields are actually being used, which fields are not being used? How can I figure out when I can deprecate certain back-end microservices that are exposed through the GraphQL schema? Which fields are being used? Which fields can be deprecated? How often are native mobile clients asking for certain fields versus web clients? Are there different behavior patterns there? How does it change across client versions, right? So providing this rich insight across different client types, client metadata, client versions, a very GraphQL query-centric view about how your fields are being used, and then as well as performance and kind of helping you optimize how you've implemented GraphQL. So it's that kind of set of the genre of capabilities of what we're looking at with this tooling.
Yeah, and so if I understand correctly, right now this works just with JavaScript servers, right?
Yes.
Do you have any plans to make that work with other types of servers?
Yep, good question. So the preview is for JavaScript servers, and we're exploring ways and expanding it to be backend server runtime agnostic. And it works with different client types, so really in a bulk client. Yep.
All right, thanks a lot, Rohit. Let's give him another round of applause.
Thank you.